Okay, so let's investigate the formula for continuously compounded bank interest. We have our the principal amount, we have our interest rates, we have the number of times it's compounded, and t is going to represent time in years. All right. So, well, we're going to have to treat this problem like we treated the other one. We're going to have to say, okay, I'm going to assume that this equals somehow, and we're going to try to figure out what that is. However, just on the previous problems, we have the problem that we have an exponent inside of this. So we're going to have to do a logarithm, and we do the logarithms because that allows us to pull the exponent outside of the problem. So the natural log of L is 1 equal to limit as n tends towards infinity of the natural log, big outer parentheses, p naught, now 1 plus r divided by n raised to the nt. And so now we need to start thinking about what are my laws of logarithms that I can use to evaluate this problem, okay? Well, the first law of logarithms that we can use, I mean, we covered this on the last test when we started doing, remember when we were breaking things apart? So the natural log of A times B is the natural log of A plus the natural log of B. So that's going to allow me to split this in half, kind of. So the natural log of A times B is the natural log of A plus the natural log of B, okay? And then we have our other rule involving logarithms is that this nt, I'm allowed to pull that to the outside. Now, n is tending towards infinity, so this is just a constant. We're not going to pay attention to this one. The t is just time. We're not going to pay attention to that one either. What we really care about are the n's in this problem. So if I send n towards infinity, this n is going towards infinity. This one is going to turn this guy into 0. We get the natural log of 1, which is 0. And so I'm going to do the same thing I did on the previous problem, where I'm going to pull this in down to the bottom. Okay, so now at this point of the problem, the top of this thing looks like the natural log of 1. So the natural log of 1 is going to go to 0, and 1 divided by infinity is also going to go to 0. So now I have the problem that's other form, the form 0 divided by 0 so that I can use L'Hopital's rule. We're going to ignore this right now, it's just a constant. Okay, so we can say that is 0, that is 0, tending towards 0. Phrase myself. So that would equal the limit as n tends towards infinity. Let's leave the natural log of p naught alone. Okay, we're going to ignore the t. Let's just treat the t as a constant at this point. And so that's going to be now plus, okay, so t. And the natural log, what is it going to do? It's going to force whatever's on the interior of the natural log down to the bottom of the fraction. Okay? So that's the first step. Taking the derivative of the natural log, let me make that t a little bit larger, just so we don't confuse it with a plus sign. Okay, so that's a t, very elongated t. Okay, all right, so we took the derivative of the logarithm and forced that guy down to the bottom of the fraction. Okay? So I'm just working on the top right now. Now, the interest rate is also a constant. Are interest rates constant in real life? No, unfortunately not. Or depending on your banking system. It's not the answer to that. So let's assume that the interest rate for this account is constant. And so when I obey the chain rule, the r is not going to be affected, but the r is still multiplied by the 1 over n. So I'm just taking the derivative of 1 over n with respect to n, okay? So it does the same thing that we did on the last problem, similar thing. Let me rephrase myself again. Negative r divided by n squared, okay? Now the derivative of the bottom is also going to be, but this guy's just going to be negative 1 divided by n squared. Okay. So now at this point of the problem, you think negative 1 over n squared and negative r over n squared, what's going to be left from this thing is just going to be an r. Let me start it up. Okay. Okay, so what are we going to get from this? We're going to kill off the negative 1 over n squared and that, but we're going to leave the r alone. And so that's going to equal the limit as n tends towards infinity. Okay, natural log of p naught. Now plus, okay, t times r divided by 1 plus r divided by n. Okay, so at this point, we're sending the limit as n tends towards infinity. So as n tends towards infinity, this term right here is going to tend towards 0, so this just becomes 1 plus 0. So we can evaluate the limit at this point, and that's the natural log of p naught plus rt. Okay. But remember, this is basically mathematics. Whenever you're using equations, it's one long sentence with a bunch of stuff in the middle, but it's really one statement. Okay, one statement with a lot of explanation leading to it. So the natural log of L is going to equal the natural log of P naught plus RT. Okay? So it really is just a statement of this. Actually, this is one of the confusing things about mathematics, is sometimes mathematicians will skip all the steps in the middle and just jump to this, and you're like, how did you get there? But this is ultimately the statement that we are dealing with. So we have natural log of P naught plus RT right there, and the very first thing that we had was that natural log of L right there. So natural log of L equals until you get to that. Okay? So at this point of the problem, we want to solve for L. So what we're going to do is we're going to raise both sides of this problem above E. Okay? The right-hand side is going to take a little bit of finessing to do, but the left-hand side of E to the natural log of L is just going to be L. So L is going to equal E to the natural log of P naught plus RT. And guys, these laws of logarithms, if you plan on going further in math, you really need to get these down. because I have some of my differential equation students who don't understand laws of logarithms. And they become very important when you start getting into differential equations. So, okay, great. All right, now what is the laws for exponents that we can do on this point? Well, the laws for exponents says I can break this up, and so the natural log, e to the a plus b is the same thing as saying e to the a times e to the b. So that's going to be e to the natural log of p naught times e to the RT. So I can break the guys up in that way. Now e to the natural log of p naught, well, e undoes the natural log, and we just end up getting that this is p naught e to the RT. And some of y'all business majors might know this as the PERT formula. Well, where does it come from? This is where it comes from.